Today we're going to be working on an FRQ that has to do with a slope field and a differential equation. So looking at part A, use on the axis provided, sketch a slope field for the given differential equation at the 12 points indicated. So we've got 12 points. We're going to find the slope at each point. If it helps to make a list, you can do that. Let's see, I'm going to start in this first column here. So -1, 0, -1, 1, -1, 2, -1, 3. I'm just going to list them all. I've got 0, 0, 0, 1, 0, 2, 0, 3. And then I've got 1, 0, 1, 1, 1, 2, and 1, 3. So I'm going to find the slope at each of those points and then sketch my slope field. So my slope formula comes from the first derivative, so x squared times y minus 1. So I'm going to start with the first point here. So if I plug this point into my slope here, I'd get 1 times 0 minus 1, so that's -1. So I'm going to draw that slope. -1, 1, it gives me 1 times 0, so a 0 slope there. -1, 2 gives me 1 times 1, so 1. And then -1 times 3 gives me 1 times 2, which is 2. Okay, so now I'm going to find my slopes here, this second one here. So 0, 0 gives me 0 times -1, so -1. Oh, sorry, 0 times -1 is 0. Fix that. 0, 1 gives me 0 times anything is 0. So actually, all of these are going to give me slopes of 0. Okay, last column. 1, 0 would give me 1 times -1, so -1. 1, 1 gives me 1 times 0, so 0. 1, 2 gives me 1 times 1, which is 1. And 1, 3 gives me 1 times 2, which is 2. So part A is complete. So let's go to part B. Part B says, while the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are positive. So I just have to describe where all of the slopes would be positive. So anywhere on the y-axis, we had a 0 slope, so that wouldn't be an answer. Anything 0 or less would be a negative slope. So actually, positive slopes would be occurring in this section and this section. So if I had to describe that, slopes would be positive anywhere x is not equal to 0 and y is greater than 1, right? Because at 1, we have a 0 slope on the y-axis, but above that, our slopes end up being positive, but not at the y-axis. Okay, so let's go on to part C. Part C is where we're going to get most of the points from because it's solving this differential equation. So C says, find the particular solution, y equals f of x, to the given differential equation with the initial condition f of 0 equals 3. So I'm going to rewrite this formula down. dy dx equals x squared times y minus 1. First step is I'm going to separate the variables. So first I'm always going to cross multiply that dx over to the other side. And then I'm going to divide this y by 1 over. So 1 over y minus 1 equals x squared dx. Okay, the next thing we're going to do, oops, I forgot my dy. I'm going to add that in here, is we're going to take the integral. Okay, so first thing we're going to do is over here on the left side, I have a u substitution. So I'm going to set u equal to y minus 1. du is going to be 1 dy. So fortunately, we don't have to change this at all. I'm just going to write it as the integral of 1 over u du. On the right side, we're going to take the integral. We're going to add and divide. So that would be 1/3 x to the third plus c. Okay, the integral of 1 over u is the ln of u. And now I'm going to plug in for u. So the ln of y minus 1 equals 1/3 x to the third plus c. So now before I plug in my numbers, I'm going to solve for y because, again, it's always easier to solve for y first. So I'm going to give both sides a base of e. I'm going to bring this up here. So I'm left with y minus 1 equals, and I'm going to bring this c down in front, ce to the 1/3 x cubed. Now, absolute value, I'm going to look and see the point that I have. The point I have is 0, 3 that we're going to be plugging in. That is up here, right? So it's going to be a positive value on the graph. So I'm going to drop the absolute value because I know y has to be positive up there. So I have y minus 1 equals ce to the 1/3 x cubed. And last thing I'm going to do is move that 1 over. So there's my general solution. So now, last thing I'm going to do is plug in my point so I can solve for c. So I'm going to plug 3 in for y, and 0 in for x. So here I have 0. E to the 0 is 1. So 3 equals c times 1. So c plus 1. C would equal 2. So my final answer, I got to go back and rewrite it. Y equals c, which is 2, e to the 1/3 x cubed plus 1. So I almost made the mistake of putting that plus 1 in my exponent, so I quickly fixed it. The 1 is not a part of the exponent. Okay, so that concludes this FRQ. You want to practice these differential equations a lot because they're pretty easy, especially after you practice them a lot. It's always the same steps every time, and they're worth a lot of points. So if you get one like these on the AP exam, you want to make sure you get as many points as possible.